Okay, sticking to the topic of matter, we can classify matter into three different categories: elements, compounds, and mixtures. We know that everything that is matter contains atoms. Those are things that have mass and take up space. So when we're going to classify matter, we're thinking about atoms and how they kind of make up these different things. Now, first is elements. We're going to start with the basics here. The simplest version of anything that we find on Earth is made up of elements. Elements are cannot be broken down to anything simpler. When we're talking about the smallest thing that classifies matter, it is elements. Now, think of this block chunk of gold right here. If we wanted to cut this chunk of gold in half and then continue to cut that next chunk in half and continue to do that, there's going to come a point where we can't cut the last thing in half. And what that thing is the elements or the atoms. You can't break an element down into anything simpler. This is the simplest form of matter that we will study in chemistry. Some examples are gold. We would find gold on the periodic table. Its symbol is Au. We've got carbon right here. Carbon is the essential element of anything living. That is the letter C. And then right here we have uranium, which is used to power nuclear powered things such as submarines, aircraft carriers, nuclear power plants, which can help to provide energy for cities. So these are three examples of elements, and obviously there's 118 on the periodic table, so we'll be studying a lot of different elements in this course. Next are compounds. So sticking with elements, because they are a basic building block of everything. When atoms of different elements are joined together, they form compounds. So whenever we have two or more elements that are bound together or have a chemical bond, we're going to have a compound. Now, one thing that's important is that we need to remember that bonds in compounds are formed chemically. So the only way that we can break it is by a chemical process, such as mixing things or burning, a reaction. We're going to need some sort of chemical reaction in order to break apart a compound. Some examples of compounds: you may be familiar with water, H2O. That is a compound because we have two hydrogens and we have one oxygen. As you can see by this diagram, 1, 2, 3. There's three elements bound together, making it a compound. Another one you may be familiar with is right here. This is rust, also known as iron oxide, Fe2O3. We know things rust. It looks like it might be just changing the way that it looks, but really, if we look down at the atomic level, it is a chemical reaction in which oxygen is reacting with iron, causing it to rust. So there's a couple of compounds for us. It's just two or more elements that have a bond where they're attached together. Now, lastly, we have mixtures. We've seen mixtures before. Maybe when you're making tea or coffee, these are mixtures. Mixtures are materials that are made of two or more different substances which are physically combined. So you physically put them together to mix them. We've got tea right here, which is a mixture, and we also have oil on top of water, which is also a mixture because they're two things that are that are mixed together. Now, the main thing to remember with mixtures is, unlike compounds where they can only be separated by chemical means, mixtures can be separated by physical processes, meaning you can either filter it using filter paper, you can boil something off to leave off our residue, whatever the solid that we dissolved. You can use magnets to separate things. A lot of different physical processes that can be used in order to separate mixtures. So with mixtures, there's two types. We have homogeneous mixtures, or also known as solutions. Homogeneous mixtures, if you look at the prefix here, homo, we think of the words same, or maybe uniform. So homogeneous mixtures are mixtures in which when you have the contents in the mixture, you can't tell the difference, or it looks like it's uniform. So for instance, Gatorade, we know there's some water in there, there's probably some sugar, electrolytes, things like that, but when you look at it, it's just a uniform liquid. I can't see the individual particles in that liquid. Chocolate milk is also another example because it's uniform, everything looks evenly mixed. And then lastly, sugar water. If you put sugar into water and stir it up and it dissolves, you cannot tell that there's actually sugar in there. So homogeneous mixtures, homogeneous mixtures, or solutions are solutions in which you cannot tell the difference between the substances that are in that mixture. Lastly, we have heterogeneous mixtures. Hetero, the prefix meaning different. So when we have a heterogeneous mixture, also known as a suspension, we're going to have things together, but we're going to be able to tell that there's two different things mixed in there. For instance, we have this sand in the water. Whenever you stir it up, this first one right here, you can't really tell a difference. But as time progresses from this one to this one to this one to this one, the sand will settle towards the bottom. This is why we call it a suspension, because the particles in there are suspended. So just think, for a solution, everything looks uniform. You can't tell. For a suspension, you can tell the different layers of things that are in there. All right, so the oil in this previous slide, this would be a heterogeneous mixture. And the T right here would be a solution or a homogeneous mixture. So we looked at three different types of classifications of matter: elements, compounds, and mixtures. It is your goal to be able to differentiate these. If I were to give you a list of substances, you should be able to tell me whether it's an element, compound, or mixture. All right, make sure you're doing the stuff that's in your packets. Keep working hard. We will see you in the next video.